This video is to show the 1 second in the life of a circuit demonstration using the Lollie circuit idea. So that's where we're using Lollies, the skittles here, to represent the energy from the battery that's going to be carried around the circuit by the free electrons, so the charges that are moving in the wire, and that energy will be carried around the circuit and transferred to the loads, and the load in this case are 2 lamps, each of 1 ohm. So we're going to put some cups there to represent the lamps and to hold on to the energy that's transferred to them. That will then be taken by the lamps and converted into light and heat. So we have 2 1 ohm lamps in series. That means we have a total resistance of 2 ohms. We can see our battery is 4 volts. So using Ohm's law, we can find the current. So rearranging I, the current, voltage divided by resistance. So 4 divided by 2. There's a current of 2 amps. Now 2 amps is the same as 2 coulombs per second. Coulombs is a way of measuring the amount of charge. So that's telling us that 2 amps means 2 coulombs of charge will flow around the circuit in 1 second. So we're going to use some cups to represent our coulombs of charge. Okay, so 2 coulombs of charge that are going to go to the battery, and some energy will be transferred to those coulombs of charge that they'll carry around the circuit. So the first coulomb of charge gets to the battery. The 4 volts here means that's the same as 4 joules per coulomb. So 4 joules of energy is transferred to each coulomb of charge. We're going to represent that with a cup with 4 skittles in. So each of these coulombs of charge is a cup collecting 4 skittles, so 4 joules per coulomb. They'll travel around the circuit. They go past the ammeter. The job of the ammeter is to count how many charges pass it. So in 1 second, 2 coulombs have gone past in 1 second, 2 coulombs per second. That's equal to our 2 amps. So that agrees with our calculation over here. Now, as the cups go around the circuit, they're going to divide the energy that they have between the components in the circuit. And because we have 2 components and they're both at the same resistance, that energy will be divided equally. So in the first cup, 2 joules of energy are transferred to the first lamp, 2 to the second from that first coulomb of charge that goes past. The voltmeter here, that's measuring the difference in the energy being carried by the charges between this point here and this point here. So there was a difference there of 2 joules per coulomb of charge. So 2 skittles per cup, that's 2 joules per coulomb. That's our 2 volts. So just like up here, volts can also be thought of in terms of joules per coulomb, or the energy being carried by the charges. Same for our second coulomb of charge here going past. 2 joules of energy going to the first lamp and 2 joules to the second lamp. So again, with both of these, both voltmeters, 2 joules per coulomb of energy was transferred, so 2 volts for each of those lamps. Those cups then return to the battery, and that would carry on again the same in the next second in the life of the circuit. One other thing that we can look at is in that 1 second, how much energy was transferred to each lamp. So if we check inside of our lamp, 4 skittles, so that meant 4 joules of energy per second were being transferred to that lamp. That's 4 watts. That's our power. So power is talking about the rate of energy transfer to a component. Same for our other lamp, which is exactly the same, same resistance. So for that lamp as well, 4 joules per second, or 4 watts. So 4 joules per second being transferred to that lamp.